remember how we first talked about imaginary numbers with what was called complex form? The complex form of a number was written as a plus bi. This was way back in chapter when we first learned. When we talked about how you write imaginary numbers, remember when we did adding, subtracting, multiplying, dividing imaginary numbers? Well, you did. We did that on my own. I know those are two different people's works, right? Put her away. Don't lie to me.
I was comparing because I had it down, but then mine was weird. So I'm asking her. No, I'm not lying to you. I think I am, but literally I'm comparing.
Were you contrasting at the same time?
No, like I'm really not lying to you. Like, I already had answers and they were weird and it was hard.
Should we pull our pant legs up so that it's starting to get deeper in here? Should we walk around? Oh yeah, you're right. Yeah, I forgot about that. Considering you guys someone needed help. Good morning. That's what happens when you sit in the front row. You get the extra harassment. Isn't it great? Anyway, so way back when, we did stuff like this. Complex number, we put the real number before the real number before the imaginary. That's just the standard way of writing it. Okay. So when we wrote a plus bi, here, when we were doing this last night, we wrote it out long form a couple of times. And we said it was x minus r0, x minus r0. We distributed the negatives and we rewrote. When you did that, you got something where you had x minus 2 minus I, x minus 2 plus I. You okay with that? Then that was basically difference of squares. First term squared minus the second term squared, if you FOILed all that out. So you got, this case, it was an I squared. Okay. Now, what you might notice then is if I look at the pattern here, 2 plus I, 2 minus I, that means, I actually probably write this as this, a plus or minus bi. That's complex number, right? How it's written. If you follow the pattern for every time that you did those, you would have x minus whatever the first number was, minus the last one squared. So as you go through complex value, this idea of the shortcut for a plus or minus bi is just going to be x minus a, oops, sorry, that was like a 9, quantity squared, minus bi squared. That's going to be the shortcut, which means that last value here is always going to be positive. Yeah, it's always going to be plus b squared. Because when you take I and you square it, you get -1. And I'm subtracting the -1, so it's always going to be plus b squared. So when you go through all of it, it's just going to wind up being the quantity x minus a, quantity squared, plus b squared. And that b value is whatever the coefficient is of I. Don't know if you noticed that, because I don't think you had one that had a coefficient. But here, if you FOIL that out, you wind up with x squared minus 4x plus 4 plus 1. So what stinks about this problem, besides all the math, is that you have to FOIL out 3 things. That's really the only problem here. So you have x squared minus 4x plus 5 times the quantity x squared minus 8x plus 16. Then you just have to multiply all that out. You'll get a 4th degree polynomial. That's the nice little shortcut. If you recognize it, great. If not, you realize that you can group and FOIL and go through it. It's not terrible. It just looks kind of awful. Okay. That idea of when we talk about that use substitution, remember that use substitution, if you're comfortable using it, go for it. Use substitution is awesome for when things look like crap. It makes things look cleaner. It's like scrubbing bubbles. You got soap scum, spray scupper bubbles, and it looks cleaner. Scrubby bubbles. It comes in a can. It sprays a foam when you clean your bathroom with it. Yes, no, maybe so. Little mustache bubbles there. Scrub. What's crazy about your generation is the fact that commercials aren't going to do anything for you anymore. Seriously. The only thing that people watch that's live anymore, usually, is sporting events. Other than that, what's the point of watching live TV? You have Netflix, even if it's like regular TV, you can DVR it if you wanted to. You just fast forward through everything. You know, the news. If you watch the news with any regularity, you can watch commercials for that. But otherwise, I mean, you guys are never going to watch commercials. YouTube have ads, but you just, as soon as 5 seconds go by, you skip it as fast as possible. That's true. But you know what I mean? The idea is, nowadays, if you start thinking about advertising, they have to think of different ways of advertising. You'll see a product placement. You'll see people walking around with their thermos brand thermos. It keeps my coffee deliciously warm. Or you'll see people wearing red sunglasses for red sunglasses. It's a good look on you. I think I like it. It's pretty good. Okay. Yes, ma'am. You can put a number in front of it. Did we have one of those yesterday or no? Okay. So I know in 11th hour I did an example real fast, one like that. So let's look at one if you did have a number in front of the I value. Let's make it really easy. Let's say you have a 0 and -4 plus, minus 3i. And let's write the polynomial of that. And then we'll go back and answer any other questions that we had from the work from last night. I don't think it was terrible. I just want to make sure that this is okay with that idea. Okay. So here, since I have a -4 minus 3i, what's the other 0 that has to be there? Yeah, good. I'm glad you said the -4, because no matter what, that -4 has to be there. So the other one's going to be a -4 plus a 3i. So if you go by the pattern, a plus or minus bi, you're going to get the quantity x minus a squared minus the quantity bi squared. So if I do that, what's x minus a -4? Yeah. So I'm going to have an x plus 4 quantity squared minus, what is that then? 3, excuse me, 3i quantity squared. Okay. If I go long form, you guys okay that that's going to be an x? Yeah. X minus. If you're more comfortable going long form, I have no problem with that. And that's where I'm getting that from. I'm setting up the difference of squares. So now I'm going to get first term squared minus last term squared. And that was just shortcutting it there. That's all it was doing. Because it's the same pattern every time. Okay. So now you get the quantity x plus 4 squared minus the quantity 3i quantity squared. Well, that means 3i times 3i, which is 9i squared. 9i squared is -9, which means it's just plus 9. So you get x squared plus 8x plus 16 plus 9, which is going to give you x times the quantity x squared plus 8x plus 25. And then distribute through, and there's your polynomial. If you do the shortcut, great. If you don't, eh. Sir. Absolutely, because that's what's going to work. Because it's always going to be the quantity x minus a plus b squared. It'll always work. Whatever that value of b is, whether it's 1, 2, 7, 86, whatever. I should put 86 on the test. Just some randomly weird number. You have a what? You can press 86 squared and it's just going to write something out. It ends at 6. You don't trust me? It ended in a 6. What else you got on the ones from last night then? Anything good? I drew on 55. That word problem. Let's look at it. So when you're doing the word problems with these, with the polynomials, again, it's very similar to how we did some of the ones with the quadratics, where we have to search for values that occur. And it's just quicker to use my calculator screen. So if I go here, it's asking me from the years 80 through 96, exports in billions were modeled by blah, blah, blah. T is the number of years since 1980, which means year 0 is what year? 1980, okay? So in what year were the total exports about, bless you, 312.76 billion? You don't get that. Austin Powers, $1 million. He said billion at first when he said billion.
Wasn't he like or was he the same?
God bless him. I watched last night. Untouchables was on. I don't know if you probably have never seen that either. It's a good movie. I love the very end scene down the stairwell. It's such a cool, so coolly shot. Yeah. Elliot Ness, Al Capone. Ring ring. Hello. Hey, answer your phone. Ring ring. Hello.
Hello.
Hello. We need to get her a history book. Do you have one? Hello.
Sure.
Okay. Anyway, so you put all that information in the y equals, and then you hit the button that says table. And if you start at year 0, that means your exports were $233 billion. At 1 year later, which would be 1981, still a little bit before your time. It was 214, and then you're searching for where it got to about 312. Well, according to my calculator, somewhere between year 8 and year 9, it got that, and you did it just fine. So you could say your answer would have been somewhere somewhere in 1988, because year 0 is 80, 81, 82, 83, 84, 85, 86, 87, 88. Somewhere in 1988, exports. Or you can say after 1988. That's what you're looking at. That's really all that means. When you're searching for stuff on the calculator, you're looking for when something occurred. Okay. I look at the next one. Actually, there was one in here. I think all of these were just searched through year values. Yeah. So mental note, 56 through 59. We're going to do those tonight. Yeah, we'll have you do those 4 tonight. And then the only other thing, as I was going through the differences between what was in 6.2, what was the differences between what was in 6.8 versus what was in 6.9? 6.8 talks a little bit about 6.8 talks a little bit about the graphing of things, kind of like what we've been doing. But what's different with their graphs is they talk about, they throw right on there the idea of, actually do this real quick. If I ask you to graph this, rough sketch by hand, if I ask the rough sketch this, what are your zeros? 2, -1, and -1. When you have junk squared, that means it's junk times junk. Okay, you remember that? That means -1 has multiplicity. Okay, so you're at your zeros are at 2, -1, and -1. That just means because there's 2 of them. What happens then at the graph at -1? It changes direction. Very good. All right. What's the leading coefficient here going to be? Not the slope, but it's okay. But what is the value of the leading coefficient here? It's going to be 1/4, no matter what. When you FOIL everything out and you distribute everything through, you're going to wind up 1/4 x cubed, wouldn't you? What are your tails doing? Down up. Your tails are doing down up. You know that you have, your tails are going down up, so it's going to go here, change direction, and do this. That's all that means. All that means. What are your zeros? Yeah. Because this means junk squared means junk times junk. Means there's 2 of them. If it was cubed, it'd be 3 of them. If it was 4, it'd be 4 of them. Right? It's that quick. Yeah. There's really not much in it. Okay? That's why I was saying 6.8, 6.9 is super fast. What about this? Oops. Actually, let me do this real quick. What about that one? I want to rough sketch that via the zeros and tails. I'm going to rough sketch that via tails and zeros. So I have f of x equals -3x times the quantity x minus 4 squared times the quantity x plus 2 squared. Which means, how many zeros should this have? 5 of them. Good. There's going to be 5 zeros. Your zeros are located at 0, 4 and 4, correct, and then -2, -2. Okay, what happens at 4 then? What happens at -2? What are your tails doing? Up, down. It's negative. Up, down. Change direction. Make sure it's not lying to you again.
Can't lie to me like last.
Stupid calculator, it's lies,
I know.
right? I don't know how high up or down those dips and dives go, but it's gonna look somewhat like that. You all right? Well, yeah. Are we close-ish?
Yeah.
So it's close enough for government work? Checks out okay? Gonna have to hold me down into the bucket of water. Okay. All right. Well, there's 6.8. That was easy. I want to write the function that has those zeros now. This is 6.9. I want to write the function that has the following. It's a cubic function that has the following ordered pairs. Yep. I'm going to write the function that has a cubic function that has the following. Now, if I'm looking at this, they gave me a graph. And you know how it's kind of tough to see here. The graph is up, down. All right. I'm going to break my chair. So the graph is up, down. Does that mean it's going to be positive or negative? Negative. We know it's going to be negative. It's negative. Well, yeah, it has to be odd because of that right there. You're just verifying. I got you. So think back when we wrote out quadratics that were in intercept form. Remember we did quadratics with intercept form? We had x minus p, x minus q, and an a value, and we said f of x equals that. Where you had two zeros, a y value, and we had to figure out what the a was. What do you think is the difference between that and this?
It's a quadratic.
There's another zero.
Ah, darn.
That's it. So if these are zeros, what's the term that has -3 as a zero? If 2 is a zero, what's the term that has it? If 5 is a zero, what's the term that has it? We know that y has to equal some scalar in front of all of that. Do I have an ordered pair to substitute in? 0 and 15. -15, excuse me. So I know that -15 is going to equal a 0 plus 3, 0 minus 2, and 0 minus 5. This is going to be difficult now. 0 plus 3.
Oh.
You can check and see if the calculator is going to lie to you, but I think you can do it.
I don't know, maybe.
All right, what's 0 plus 3? 3. What's 0 minus 2? What's 0 minus 5? All right. Now, bear with me here. 3 times -2. Okay, all right, good. All right, so far so good. -6 times -5. 30. Okay, so that means that -15 is going to equal 30. A. No, it's A. I got you twice. What's your value of A? Negative half. Which means the cubic function is f of x equals -1/2 over my zeros, x plus 3 x minus 2, x minus 5. That's all it is. That's it. It's the exact same thing as writing the equation in intercept form, given 2 zeros, now we have 3. It's the same setup. Exact same setup. Because we knew that it was down, and we were given that extra ordered pair. That's how you're able to figure out how much of a dip and dive things have. So if you're given the 3 zeros and an ordered pair, then you can figure out the actual real function.
If we just got 3 zeros, there wouldn't be zeros.
You wouldn't be able to do it because you'd have to know what the other one is to figure out what the actual form. If you have 3 zeros, you don't know if it's going to be up down or down up until you have that extra point to tell you direction.
So all of these big graphs are going to have some sort of scale.
Like that is literally the point. What do you got? Good job. Again, this is, shall we say, rather simple. So we're only going to deal with these things in terms of cubics. We're only dealing with these things in terms of cubes, so you don't have to worry about fourth degree, fifth degree, anything like that. So let's try this one more time. Write the equation of the cubic function that contains the following zeros and the ordered pair. Okay? And each and every time you set it up and start it the exact same way. It does not change. We know that y is going to equal a you have your x. What's the term if negative 1 is the 0? Plus 1. What's the term if negative 2 is the 0? What's the term if 0 is the 0? And then here's your x and y value to substitute in to solve for a. Which means negative 3 is going to equal a times 1 plus 1, 1 plus 2 times 1. What's 1 plus 1?
Oh my gosh, I can't do that.
So make sure your calculator charge for this, ladies and gentlemen. 1 plus 1 is? 1 plus 2 is?
1.
2 times 3 is? Why are you still here? Skedaddle. Does this mean that every answer, your a value is always going to be negative 1/2? No. I'm surprised you guys haven't asked me if you had to FOIL all this out. That's just silly. It's okay. And you can, when you're writing out the function like that, you can just leave it. You're just finding the a value. See what I meant by saying this 6.8, 6.8 are really easy? You've done most of the work up to this point. Wait, 6 divided by 3 is 2, yes, but if you divide negative 3 by 6, you get negative 1/2. It's a very common mistake. It's funny that you asked. So tonight, what I want you guys to look at, we're going to do a couple of different sections. Not moving the cat. I have a stapler. That's the test on this one. Bless you. I think I have all these on the PDF file already too for you. So with that 6.7 stuff, those 3 problems. 6, 7, 8, 9. Sorry, those 4 problems. Those are basically like what I showed you at the very beginning of the hour where you're using the table function to search for a solution. That's what you're looking at. 6.8, those 4 are rough sketch and graph, like we did via zeros, tails, real fast. And then those last ones are what we just did, right? This morning, I was able to kind of reset up a quick review thing. If you want to get started on that, as we start looking through it. For what we're at, the only thing that's not on here really are the like these 6, 8, 6, 7, because it's kind of hard to get the actual word problem stuff. But as you can see, that's the complexity of a word problem. Throw the calculator in for a table. That's really all you got to do here. So here I've got it for you. Answers for those things are on the back, so you can start working through them. The ones that I did at the very end there, where it's the rough sketch, find the zeros and rough sketch, I made sure that those 4 have real zeros, so you can actually find them and plot them. Not like what we did the other day, where you only could plot like 2 of them and you had all those imaginary values. I can only ask you to plot ones that have real solutions. I can ask you to find zeros that are imaginary, which you'll find that there are a few of them in here as well. So I would get that stuff first, obviously, and then this is what we're going to be working on over the course of the next 24 hours or so in class and whatnot. Look at me, I'm trying. Oh, say good save. Kid never speaks, and he tells you suck. That's just great. Good work. Hi, how are you? What's up? So far away. Hold on, I have to walk away for a second. You'll have to wait. That's her highness is waiting. What's up?
For problems 9 through 12 in the review sheet, are those like set individual?
That would be the easiest way to find them. I mean, unless you want to group them, because I'm looking at those numbers, you can group them too. Remember, when you're doing these things, it's totally up to you if you want to use synthetic or you want to use grouping or any of the methods possible. Because that's on you to figure out what's the best way to go.
Yeah.
It might take too much time. You only have so much time to take tests and stuff.
Yeah, that's true.
You recognize the patterns, it's better off. Yeah, I believe.
Now, if I work these, like 9 and 10 would be the obvious, but like 11 and 12 is like 8, 4, and 1, 8, 4, and constant. I just like divide it to like 8, 2, 2, constant.
I'd have to look at the problem because everything's different. I can't remember what it was off the top of my head. I just want to say this. Just so you guys know, I do have the 3 different PDFs of 6, 7, 6, 8, and 6, 9 on the calendar for today. So 6, 7's there, 6, 8, 6, 9's there, and the review thing in case you do lose it. So the review's there with the solutions to it. We'll go through the answers then tomorrow as far as the book stuff's concerned. I really don't think you're going to have an issue with those word ones. They're super simple. We can go from there. I know on the review sheet that I gave you, remember how we did that one I value, that A plus BI, where the B value was like 4? I think I have one like that on here, so you can practice that one as well and go from there. Okay? Usually you guys do pretty well on this one. Yeah. I didn't mean to call you your highness. I was What's that? She's trying to. She's talking smack to me. Lily, she's talking smack to me.